Assalamualaikum and hello everyone. In this video, me and my group members will be presenting about the application of nanotechnology in food industry. The revolution of food nanotechnology started from pasteurization process that was invented by a French microbiologist, Louis Pasteur. Pasteurization process is a process in which packaged and non-packaged foods are treated with mild heat. This process is meant to destroy or deactivate organisms and enzymes that contribute to spoilage or risk of disease. There are four types of nanotechnology application in food industry, which is food production, food processing, food supplements, and food packaging. In this video, our group will be focusing on food processing and food packaging. Food processing is the process of changing raw ingredients into food and its other form, while food packaging is a process that enclosing food to protect it from tampering or contamination from physical, chemical, and biological sources.
The material used in this process was gelatin for the biopolymer, eucalyptus fiber for cellulose nanocrystal, and glycerol for plastifier. For the production of cellulose nanocrystal from eucalyptus fiber, the procedure is as shown in this diagram. Submerge 10 grams of fibers in 200 ml of NaOH solution for 4 hours at 60 degrees Celsius. When pH of 7.0 is reached, the solution will be filtered and washed and the material dried at 14 degrees Celsius. And then the dried fiber in step 1 was added with 300 ml of combined solution of NaOH plus CaOCl2 and was let to rest for 4 hours at 45 degrees Celsius. The solution was filtered and washed until it reached a pH of 7.0. The material was then dried at 40 degrees Celsius. 250 ml of sulfuric acid 60% undergoes vigorous stirring for 30 minutes at 55 degrees Celsius with the fiber treated in it. After that, the hydrolysis reaction was stopped and the sample was centrifuged until the CNC were in suspension. 72 hours of dialysis will be done to the suspended solution. Using a transmission electron microscopy, the shape and the dimension of the cellulose nanocrystal were assessed. Performing this procedure starts with a drop of nanocrystal suspension diluted in 2 ml of isopropyl alcohol and placed in an ultrasonic bath. For 10 minutes is analyzed. Alcoholic dispersion was deposited on the special grade for 24 hours and 2% solution of uranyl acetate covers each film. Then the material was dried at room temperature before being assessed. The strawberry was sanitized using sodium hypochlorite solution and then recoated with filmogenic solution. The weight loss in the strawberry that was not coated had lost much weight, as high as 65.8% of its total weight. The ones that were coated only lost at maximum 35% of its weight. Using gelatin containing cellulose nanocrystal coatings had indeed proved to be extending the strawberry fruit shelf life. The fresh strawberries were able to maintain freshness by applying the edible coating, and this can help the fruit harvesters to extend its long conservation period between them and the consumer. The advantage of applying the coatings to the strawberries is that the fruit were visually fresher and better looking, with no rupture zone and presenting natural bright.
Another application of nanotechnology in food industry is food packaging. Packaging is the technology of confining or protecting products for storage, distribution, sale, and many more. Packaging maintains the benefit of food processing after the process is complete. Thus, it enables food to travel safely for a long distance and still be wholesome at the time of consumption. So, the primary purpose of food packaging is to protect the food against attack from oxygen, water vapor, ultraviolet light, and both chemical and microbiological contamination. Packaging has a lot of functions such as preservation and quality, provide storage history, product containment, and also act as presentation and convenience for the customer. Active packaging refers to the incorporation of certain additive into packaging film or within packaging containers with the aim of maintaining and extending product shelf life. Active packaging helps package to interact with food and its natural environment, and does it play an important role in protecting the food. The use of active packaging are preserve the quality of food during the shelf life. Next is to decrease the food loss. It is also act as marketing tool and to develop new products. It is also to increase the food safety and to extend the shelf life of the product.
Oxygen scavengers. This is example of oxygen scavengers. I will explain about mechanisms of action of oxygen scavengers. Food deterioration caused by oxidation reaction or by the presence of aerobic microorganisms. Oxygen presence in food package is mainly due to failure in the packaging process, such as mixture of gases containing oxygen residues or inefficient vacuum. Oxygen control is one of the ways to preserve food which modify and control at microatmospheric level within a food package to remove oxygen required by organism. Oxygen absorbers are small packets that contain an iron powder. The packets are made of a material that allow oxygen and moisture to enter but do not allow the iron powder to leak out. It is used to remove oxygen from within a sealed environment, creating a nitrogen environment for long-term food storage. It is applied to the products which low in moisture and oil content. Oxygen scavengers contains iron powder which reacts with oxygen in air, causing iron powder to rust. When all iron powder has oxidized, the oxygen absorbers are loaded and absorbing action stops. The oxygen is then removed from an active absorber and the chemical reaction stops. It is then put back in the air and the reaction starts again until the iron is gone. Next is properties of oxygen scavengers. This is chemical reaction for oxygen scavengers. Ferrous oxide becomes activated with moisture and it will commence absorbing residual oxygens to oxidize to a ferric state. Then it will react with water to produce a reactive hydrated metallic reducing agent. Oxygen scavengers is safe to use, even though it should not be eaten as it presents a choking hazard. Oxygen scavengers is used non-toxic contents. That's all from us. Thank you.